Here we have the infinite series 1 divided by n to the n, and we want to show that this infinite series converges by using the direct comparison test. And once again, to use the direct comparison test, we have to come up with a infinite series b sub n. And then we have to show two things. The series a sub n, which is the given series, is less than or equal to the series b sub n. And then we also have to show that the series b sub n converges. And for something like the 1 over n to the n, let's compare it to 0.9 to the n. And so this is the given sequence, and then the b sub n, we let it be 0.9 to the n. And the series b sub n, we do know something about it, because this is a geometric series with common ratio of 0.9, and we know that for geometric series with the common ratio between -1 and 1, the series converges. And so that's why we use the 0.9 to the n. And so now let's compare the a sub n with the b sub n. The first column is the a sub n column, and the second column is the last column here is the b sub n column. When n is 1, then we get 1 here, and we get 0.9 for the b sub n. When n is 2, we get 0.25 for a sub n, and we get 0.81 for b sub n. When n is 3, we get 0.037 for a sub n, and 0.729 for the b sub n. So with the exception of the when n is 1, this is greater than, but this is less than, and in fact it's going to be less than after from when n is 2 or more. When n is 2 or greater, then the a sub n is less than the b sub n. So for n greater than or equal to 2, a sub n is less than b sub n. And then if we what do we do with the first one? Where the a sub n is greater than the b sub n? Then what we can do is something like this, similar. We look at the sum of the first 10 terms for the a sub n. So add these 10 numbers together, we get 1.29. And then the sum of the first 10 terms of the b sub n is 5.86. So we can see that the a sub n is less than b sub n when we compare the sum of the first 10 terms. And then after term number 10, and then a sub n will be less than b sub n. And therefore we can say that this series right here is less than the series 0.9 to the n. So once again, the sum of the first 10 terms of this series is less than the sum of the first 10 terms of this series. And then after term number 10, meaning term number 11 and on, this series, the a sub n is less than b sub n. And therefore we have this result right here. And so we have just shown that series a sub n is less than b sub n. And now we also need to show that the series b sub n converges. This series is a geometric series, with common ratio and so the series converges. Recall that for a geometric series, if the common ratio r is between -1 and 1, the series converges. And so we have shown two things. The series 1 over n to the n is less than the series 0.9 to the n. And then we have also shown that the series 0.9 to the n converges. And therefore, by direct comparison test, the series 1 over n to the n converges. So we have shown two things. A sub n, series A sub n is less than series B sub n, and we've also shown that series B sub n converges.